Hey everyone, welcome back to another video. In this to another video series. In this video series, we are going to take a 100-day integral challenge in which we are solving 15 integrals per day, making a total of 1,500. The goal of this is, of course, to get better in calculus. So, what we're going to do first, before we start with this 100-day challenge, is to get some idea about some good formulas and techniques. One of my favorite is integration by parts or partial integration. Let's say we've got this formula. We just can't take the normal product rule because this doesn't work because of this. So what we instead have to do is we have to take another formula, which is pretty easy. So we know the form of this, so f to the derivation of f times g equals to fg minus the integral of f times the derivation of g. We've got one big problem here. So this is not equal to this. Before we have to take the derivation of one formula. So we have to declare which of those is our derivation. So let's write this down. Let's say we have our f, and let's say we have our g. And then we have the derivation of both, because we need both. So let's be smart. What is the best idea what we could do here? And this is quite simple. So what we want to do is actually we want to declare our f, in this case our x, and our g, we want to say this is this. So we say this is nothing else than x times and then let's say so, and then we have to find the derivation of e to the power of 2x. This is the idea behind this. So let's do this. So f in this case is nothing else than x, as we already declared. Let's write the formula here. So we know this is x, and therefore this is 1. You see, we want to take this because if we find the derivation of x, this is nothing else than 1, which is quite nice. And then, oh, I'm sorry. I meant the other one. So, man. Hey everyone, welcome back to a multi-video series. In this series we want to take a 100-day integral challenge where we solve 15 integrals per day. Since we are going to solve a lot of integrals, it might be good to have some basic techniques before we start. One of this is integration by parts or partial integration. Let's take for example this here, so x times e to the power of 2x. We want to find the integral of this. We can't just use the normal product rule because of this. So what we instead have to do is we're going to have to take this formula. So we're searching for integral which has a derivation times of f times g. It's nothing else than f times g minus the integral of I'm sorry, there is something missing. The derivation of g. Be careful. We can't just say this is f and this is the part g because of this. We're searching the derivation. So of one of those two we want to do the derivation, and normally we want to do the derivation of the thing that is harder to calculate. The reason for this, or not always harder, but for example you see if we have x and let's say we find the derivation of this is nothing else than 1, because so if f of x equals to x, this equals to 1. So don't get confused. We don't want to use this f, so this f is another thing. So if we have something quite easy like this, we want to say this is our g. The reason for this is quite simple. You will see just in a second. So let's say for example, so let's plug this in our formula. Let's declare we've got f and we've got g, and we then get the derivation of f and then the derivation of g. As we already declared, we don't want to take our x in this case as derivation, but instead we want to say that our e to the power of 2x is our derivation. So let's write this in. So this is our derivation. Now we have, of course, to find the integral. So the integral of this, so what you can say is, well, maybe this is a bit better, is this is nothing else than this. Yeah, but it makes no difference since the principle stays the same. Not f of so. This is quite easy. We use just normal integration rules. We have this times n, so this is nothing else than 2, 1/2, and this just stays the same. Same thing with g. So now we know our g is x. This means we're just going to find the derivation, and this is 1. And this is basically it. Just plug it in our formula, and what we get is pretty easy. We get f times g. What is our f? Of course, 1/2 times e to the power of 2x times x minus the integral of, and now that's the reason why I said we don't want to have something weird, because now we just plug in the 1, and we know 1 times something is just something. So we just plug in our, and now be careful, f. So we search the integral of 1. So this is the thing we want to search for. Now we just say this is nothing else, then let's write this down clear. Let's solve the integral first. So we just write this here. So this is 1/2 times 1/2, or 1/3. So this is nothing else than 1/2 times e to the power of x, and then that's 1/4 times e to. What can we do now? Because personally, you can say that that's it, but I personally don't like this because it's a lot of, I don't know, it just doesn't seem nice. So what we're going to do is we make a very nice trick. We just, make this, because this is basically the same thing, and we say this is nothing else than 2x divided by 4. So if we have a mathematical eye, you can even simplify this further. If you say this is nothing else than 2 times, because we want to have the same fraction, so we just multiply this by 2, we get here 4. So this is 2x minus e to the power of 2x divided by 4. And this is then nothing else, because of normal rules, minus e to the power of x divided by 4. We can even simplify this further if we just think we have 2 terms in common. So we just say this is nothing else than 2 to the power of x. And now we just say 2x minus 1 divided by 4. And I personally think this is quite nicer formula than this. Yeah. This is like the principle behind this. Let's take it even further with an example, an ln of x. If you know the integration of ln of x and you always wonder why this is true, congratulations, you can now solve this by yourself. Let's apply our formula and say f times g equals to fg minus f times g. So, of course, you know what I mean. So now you say, but I only have one part. Congratulations, this is wrong. You do not have only one part. In fact, you have dozens. So, but we don't have a look at dozens, we just want to have a look at one, and this is literally one. So we can say this is ln for x, and then you can just say this is, for example, in this case, in the region of f and g, if you want to have. So let's apply this. You can solve this by yourself, by the way, if you just pause the video. So let's solve this. we're going to do our nice table where we just say this is f and this is g, and this is f and this is g. So let's start. We apply our 1 here, so this goes to here, and we say what is the integral of 1, it is x. Now just write this here, so we get ln of x, and we know that the derivation of ln of x is 1 over x. 1 over x. Is it correct? 1 divided by x, and not 1 over x. 1 divided by x, I'm so sorry. Just plug it in your formula, and this is quite easy. So what this makes is x times ln of x minus the integral, plug in x, times 1 over x. Simplify this, and we get x times ln of x minus the division of this. So this is nothing else than x times ln of x minus the division of 1. And now be careful, because you still have to find the derivation, the integral. I'm so sorry, I can't speak English. Be careful of the integral, because the integral of 1 is equal to x. So it's x times ln of x minus x. If you're funny, and we are funny, we still want to simplify this, but in this case you actually can leave it by. But you can actually say this is nothing else than, you just take this out, this is nothing else than x times can we do this? I think we can, right? We can say this is nothing else than ln x minus 1, right? Yeah, we can, of course. Yeah, I'm so stupid. So this is my, so yeah, this is the same thing. So this is, so those both things are about solutions. So let's take it a step further, and let's replace the 1 with the x. Pause the video and just try to solve this. So I just prepared it, I just calculated itself because I'm tired and I want to go to bed. So we do the same idea, it doesn't matter which part you pick, as always I prefer the x as over f this. So we plug it in, so we know x gets to 1/2 x squared, and then we just plug in ln of x, and we know this gets to 1 divided by x. Plug it in your formula, you get 1/2 times x squared times ln of x minus, the integral of 1/2 x squared minus. So this is nothing else, you just plug in, so you just bring this here, this is x squared divided by x, you get 1/2 times x squared times ln of x, and so on, minus the integral of this, you just form the integral, so 1/2 x, so the integral is nothing else, you go with x, and you just multiply this by 2, so you get this. You do the same trick like before, you multiply this with 2, so you get an equal fraction, not an equal fraction, but you know. So you can subtract this fraction by this fraction, you write this in this, and then you just factor out the x squared, and what you get is this. Quite simple, right? So I think if you understand the concept, you understand a lot of things if it comes to integrate by parts. I hope this video was helpful, and we'll see us very, very soon. Goodbye.